Good morning, everybody. Today I'll be talking and giving an introduction to .NET Aspire. This is a cloud native application development framework developed by Microsoft to make the development of distributed, observable, and make it easier for developing any cloud native applications. So whether we are building a microservices or working with cloud-based infrastructures, .NET Aspire helps reduce complexity and improves productivity. So let's start by defining what is .NET Aspire. It's a framework built with cloud native applications in mind, targeting developers who need to develop and build distributed, scalable applications efficiently. .NET Aspire simplifies cloud native development by providing some pre-built-in tools for handling the common challenges of microservice architectures like service discovery. Like I'll go through in the code and show you how Aspire discovers the services and orchestration and configuration management. Aspire is fully integrated with .NET ecosystem. That meaning it leverages like all the strengths of .NET, including cross-platform capabilities, and it has great tooling support and integration with cloud services like Azure. So now let's a closer look at the key features of .NET Aspire that makes it such a powerful tool for cloud native development. Number one, simplified cloud native development. Aspire abstracts a lot of the complexity involved in creating cloud native apps. So we can focus more on the business logic rather than the infrastructure setup. Number two, orchestration and service discovery. It manages inter-service communication and discovery, reducing the burden on the developers to configure this manually. Number three, pre-built integrations for common services. Aspire, it comes with integrations for popular services. If you haven't heard about like Redis caching, that's one of the popular one for caching, PostgreSQL and Azure, making easy for like setting up caching, messaging, or database services. And the next one is tooling and templates. This framework includes project templates. I'll show you in the Visual Studio how you can quickly bootstrap new projects and saving developers time. And the fifth one is distributed application support. Aspire is built to handle large-scale distributed systems, which are essential for cloud-native applications. So if you see this, one of the standout features of .NET Aspire is its orchestration and service discovery capability. When working with distributed systems, managing communication between different microsystems or microservices can be challenging. I know we don't currently use any of the microservices, but some of the organizations, they use these microservices. So Aspire solves this by automatically setting up service discovery, which I'll show it in the code later, meaning that different parts of your application can easily find and talk to each other without manual configuration. Similarly, orchestration involves managing how different services in your application are connected and interact with each other. Also, Aspire handles much of the complexity of orchestrating these services, making your own development process smoother and faster. So with these, you don't have to worry about how these services communicate across your cloud infrastructures. Aspire takes care of for you. And there are like, these are the pre-built integrations, as I mentioned earlier, Redis, Postgres, and Azure Service Bus for messaging and SQL Server. And another one is automatically it sets up the necessary configuration like health checks, logging, and telemetry. These helps us like to easily monitor and ensure health and performance of these applications without having manually configuring these services. The tooling and templates, Visual Studio, if you go through Visual Studio or CLI, .NET CLI, there are like two main templates. One is Aspire application. This is the minimal. This template is a minimal and allows you to build out your own custom cloud native app. And the next one is Azure Starter application. This template includes more boilerplate code, including sample UI and API components. And I'll show you an example where it has the API and Blazor UI and how it interacts with those two with the .NET Aspire. This template will give you starting a new project with a solid foundation. And what are the benefits? Why we need to choose .NET Aspire for your next cloud native project? One is the simplified configuration. Aspire handles many of the common configuration tasks that developers usually need to do manually. This reduces errors and saves time. Cross cloud compatibility. I know we don't currently use it, but some of these Azure and AWS and other cloud providers, Aspire offers flexibility to run across different environments. And the third one is production ready components. Everything Aspire offers in built in with production in mind. For health checks, like from health checks to telemetry, Aspire ensures that your apps are ready for deployment in highly traffic environment. That makes it scalable, maintainable, and production ready cloud native application. How do you get started? Install Aspire via Visual Studio or .NET CLI and choose one of the available projects template to build your application, like app host and the service default projects will be included in the setup. There is a template you select when you go into Visual Studio. From there, you can add like the necessary services, the SQL Server or the Redis caching or whatever that you need. I'll go through the demo and show through Visual Studio how this architecture and different services. So if you see this, I got a Visual Studio, and these are the 4 different projects I have in here. So first one, I'll go through the Aspire app API service. This is a .NET 8 Web API with the service defaults. If you see this one, it has a reference to the service defaults. And if I go into this program.cs, and you will see it uses the service defaults, and it has an endpoint exposed to get the weather forecast. I'm using the weather forecast sample. And also it has another Aspire extension method, map default endpoints. So these are the ones, app service, and this is the another weather forecast. And the next one is the Aspire Web. This one is a ASP.NET Core Blazor project with the service defaults. You see this. Service defaults, this one. As I said earlier, this is a Blazor frontend, and it also adds the default services and some components, and Azure component add interactive server components. And if you notice here, has a service, API service. It doesn't have any local host or port number. And this is like the standard when it comes to the ASP Aspire. So now we don't have to worry about what is the port number and how we don't have to remember all those. So ASP Aspire app host. Next, we focus on the Aspire app host. This app host, this is an orchestrator project designed to connect and configure different projects and service of your app. Like if you see the project references, right here, it has the Aspire API service and the Aspire web. Those two are referenced. And if I go into the code of this, you see the first line. Sorry, wrong way. But oh, this one. All right. The distributed application. And if you see this one creates an iDistributed application builder instance by calling distributed application.create builder. So this is the starter project. We have like 4 projects here. So app host, service defaults, web and API service. This is the one. App host that is responsible for acting as orchestrator. And it says the Aspire host property. It's true. So where do you find it? Like if we go on like right click and edit project, right? Then this is what you see. And this is what you see. Aspire app host is true. And as I told you, it has like 2 project references and the SQL. I played around with the SQL database and you can see the references to have an SQL DB here. So as I said earlier, this project has 2 references and SQL database. And this one calls, when I go in here, it is calling this API service or is given a generic type parameter project details. Now it is adding API service, Aspire of API service. So this is one of the fundamental building block of .NET Aspire. Okay. And this is used to configure service discovery and communication between the projects in your app. So the name argument API service is what you see here is used to identify the project in the application model and used later by many project the way you want to communicate with. So next one is like calling the add project again, and now it is calling the Aspire web to the application model. Now it also changed multiple calls with reference passing an API cache service. Now we are using that service. We are not calling any caching or anything. Now this one, the next project, API service default, if you see the extension, that's what everybody's calling, right? Like if you go back to the program.cs and see here is calling this service default. So when I go to the service defaults and extensions, and this is the one we need to focus on. So if you see this is what like the command is, this is the shared project. How do you know it's a shared project, right? If you go in here, so this is shared project is set to true. That's one thing. And if I come back to the extension class here, if you see IR service defaults, this is what like some of the it manages the configuration related to the project in your solution related to resiliency, service discovery, or telemetry. And also it configures the open telemetry and default health check options, service discovery functionality, and configures the HTTP client. All right. This one. So if I come next one, it is calling the configure telemetry. If you see this, it is logging, open telemetry, and tracing and the metrics, right? So logging. The log events describe what is happening when as an app runs, right? A baseline is set, is enabled. What .NET Asper does is it integrations by default. It is enabled by default for more extensive logging. Can be enabled on-demand diagnosis also particular problems. You can, it's basically logging is know to go back and see, oh, what happened when you're on the application or something is happening. And the next one is tracing, correlates even some logical activity spread across like multiple machines or processes. And metrics is the something you want to see how the application performance is like health characteristics on app with some numerical values. It has like show the low performance overhead or how services configured, right? And also it can use like suitable for triggering alerts when potential problems are detected. You see the last one, if I scroll down here, the health and alive, those both will health endpoint indicates app is running normally when it's ready to receive requests, and alive is the app is if an app is running or has crashed must be restarted and must be restarted, right? So with there are like some limitations as you see, adding health checkpoints in non-development has security implications. So you got to be careful when you're trying to use this. Otherwise, there may be some DDoS attacks can happen. So you got to be make sure. Right, let me run this application. Currently, I'm using a Podman as a container. I know you can use a Docker or Podman, but this system supports Podman. So started using Podman. And it is building the application right now and brings up the browser. Let me show you the browser here. Right. Now, if you see this, you on the left-hand side, resources, console, structure, traces, and metrics. Resources like list basic information. Okay, what type of project, either it's a project or a container or a resource, and what are the name we gave, and the state of it, and the endpoints, and you can view the logs and details. Right now, if you click on this endpoint, and this is the front end, it will show it. And this is your front end application, a Blazor application, and the weather, and it's calling the SQLDB to create a table and try to get the get out of it. Takes a little bit of time. Like this is the API is giving you the results in a JSON format, and this is the data that's coming from the database table. And the console, if you can select different resources, API service, it will give you what is happening when you run the service and the web front end. Next is the structured. You can filter. This is in a basic default, and it is filtered. You can filter by or like by resource type. And the next one is the traces. This is what more interesting for me, at least. When you make a call from the weather, it is what it is showing. What is that? It's making a call, and how and the call is it's making to a database, and how much time it took it to the retrieve the data and display it. Right? So if we come back here and click on this, now we come back to the phrases. Right, this is what you see. Now see 1.86 milliseconds. And the last but not the least, if you come back here, the sequencer objects, now you'll see how the databases is there on the table. If you can expand this, then you will see the table on the related data here. So that's all I got. And one note I learned is this is only for local development only. We can't publish it out. Right now they're with all the containers, and it is trying to mimic your cloud on your local basically, and try to troubleshoot and see how the app is performing, and utilize this dashboard and see how the resources and the console are like traces and metrics. I didn't mention anything about metrics, right? We can see how many requests and the duration and the connections and all that. You can explore all these and see how beneficial this aspect is. All right, that's all I got. Thanks for joining. Have a good day. Thank you.